Hi, I'm Afi.
Hi, I'm Elisa.
Hi, I'm Kaberjin.
And my name is Lydia. Hi.
Hi, we are
Luceda Stella.
Ha!
So now I'm going to present the introduction of the topic. What is differentiation? Differentiation is the method of finding the derivative of a function which gives the rate of change of the function with respect to its independent variable. Why do we need differentiation to solve our problem? This is because by using the application of differentiation, it allows us to determine the rate at which quantity changes concerning another. This is useful in understanding dynamic systems where variables are interrelated, such as the rate of water volume that flows. What is related rates? It is a calculus concept that deals with the analysis of how the rates of change of two or more variables are connected. Why do we use the related rates? It is to find the rate of change of one variable in relation to the rate of change of another variable. It is useful in situations where multiple variables are changing with respect to time. So now I'm going to pass to Lydia for the problem statement.
Okay, thank you, Elisa. So now I'm going to explain about our growth problem statement. So Annalise is living in a double-story house located in Kota Kinabalu City. The housing area always facing water supply problem, so her house uses corn water tank as water supply. The volume of the water tank is 1,515 liter. The radius of the corn water tank is 0.5 meter while its height is 2.2 meter. However, the water supply from the tank is not enough for the whole family members to use. The water needs to be supplied to the whole part of the house, such as the kitchen, bathrooms, front yard, and the backyard. So as a friend, we would like to help her fix this problem by modifying the height of the water tank. According to our research, the rate of volume that flows is affected by the height of the tank. The initial rate of the water flow is 0.018 meter cubic per minute. So we want to increase the rate of water volume to 0.03 meter cubic per minute so that water supply is sufficient to be used in the house. So next, I'll pass this to Afiq.
Okay, thank you, Lydia, for the brief explanation of the problem statement. So we will dive into the calculation. So first, we need to have the volume of the cone-shaped water tank, which equal to 1 over 3 pi r square h. So this one will be the first equation. For the next one is we will using ratio between the radius of the cone and the height of the cone, which equal to 0.5 over 0.4. So after cross multiplication, you will get radius equal to 5 over 4 hash. For the next part, we will need to sub equation 2 into the equation 1. So volume equal to 1 over 3 pi multiplied by 5 over 4 h square multiplied by h. So you will get volume is equal to 5 pi h cubic over 12. To get rate of changing volume over height, you need to let u equal to 5 pi h cubic and then different it become 15 pi h square. Then v is equal to 12 and differentiate it become 0. For the next part, you need to use quotient rule, which is u multiply by du dx minus v multiply by dv dh over 12 power of 2. So the answer will be 5 over 4 pi h square. So dv dh over dh is actually rate of change of volume over height of the cone. Thank you. I will pass the next question to Cabera.
Thank you, Afiq. So for the next part, I'm going to continue to find the rate of water volume flows in the house when the water level dropped from 0.4 meter to 0.3 meter by using the chain rule. So to use the chain rule, it is dv over dt equivalent to dv over dh times dh over dt. So as for the dv over dt, it is equal to 0.018 meter cubic per minute, and we need to put negative sign since the water level and the volume is keeping on decreasing. So as for the dv over dh, it is 5 over 4 pi times with the height, which is 0.3, and we need to square the height and then multiply with dh over dt. So in the end, dh over dt is equal to negative 0.051 meter cubic per minute, because it is in negative sign because it is decreasing also. However, there is a problem, which is the rate of water volume is not enough to be supplied to all parts of the house, but especially when the family members want to use the house. So the new modification that we want to suggest is we need to find the new height and increase the height of the cone, which is located at the bottom of the water tank. So in order to find the new height, we also need to use the chain rule. However, at the dv over dt, we change it from negative 0.018 meter cubic per minute to negative 0.03 meter cubic per minute. Meanwhile, we just keep the rate of change of height over time same, which is 0.05 meter cubic per minute. So in the end, we're going to get the height equals to 0.39 meter. However, as for the new height, we must plus it with 0.1 because we want to find the exact time when the water is still full. So we will get 0.49 meter for the height of the cone. I think that's all from me. I'm going to pass the next presentation to Alisa for the conclusion. Thank you.
In conclusion, the application of differentiation helps to find the rate of water flows that needed by the house. Then, by applying the principle of related rates, we can find the desired rates of change of height over time because the rate of water volume that flows is affected by the cone water tank output.